Спасибо.
Okay, great. I see some active members of our webinar in the Zoom chat. It's really good, guys. So you can ask any questions in our Zoom chat, and we will be glad to answer on it during our webinar. Okay, so we are ready to start. And first of all, I'm going to share my screen with the presentation. Okay, so good. So today our webinar number 4, and today we will tell you about how to work with a real Clover drone. First of all, let me introduce myself and our lead trainer, Timofey Kondratyev. So my name is Svetlana Solomatnikova, and I'm Drone Competitions and Activities Manager of Copter Express. And I'm trainer since 2017, and I was a WorldSkills Juniors Chief Expert at WorldSkills Kazan 2019. And Timofey Kondratyev. Timofey, he is a technical programmer of Copter Express. He is a trainer since 2018. He provides many project activities with Clover and more. So, Timofey, would you like to add something?
Well, I like working with drones, and I like to teach people how to do that too. And my goal of today is to make all of you
Oh, Timofey, we don't hear you.
Yeah, now you hear me.
Yeah.
To teach you how to set up the drone and how to make it fly autonomously, because it's one of the most difficult parts of programming drones, because it's not easy to describe it in all the detail in documentations. This is why we are doing this webinar, for you to learn how to prepare your hardware for the flight. So this is our today's goal, and I hope you all learn something new from that, and it will prove that you will not break your hardware and you will have a better experience working with Clover.
Yeah. Thank you, Timofey. This webinar will be very useful for you and for your students if you're a teacher and plan to provide the lessons using drones. So, and also today we will show you and demonstrate the real workshop. It is one of the big colleges in St. Petersburg. So we will demonstrate how drone flies in real time and some interesting moments of it. But also I would like to continue introduction, and also I would like to introduce our participants. So this is a really great big international community who has interest in our drones in our webinars. So we welcome teams, welcome participants from Indonesia, Canada, United States, Italy, Qatar, India, United Arab Emirates, Russia, Belarus, Germany, Pakistan, Cameroon, Ecuador, Malaysia, and Vietnam. It is really great to know that these topics are very interesting for you. So, and while we have many people from other countries, I suggest to create the common photo with you please turn on your cameras, and we will make the big common photo and share this photo in our community group. Oh yeah, I see camera from Shritam. Hi Shritam. Hi Yusuf.
Hello.
Hello, hello, hello. Shritam, you are from India or no? Or Pakistan?
Yes, ma'am.
Yeah, great,
Yes,
great.
I'm from India.
Okay, good. Thank you. So we wait some people from others. So Sarah, Alessandro. Oh, I see Samuya. Hi, Samuya, Darshan. So we wait you guys to turn on your cameras, please, and we create the common photo. It's the best memories of each webinar. Oh, I see Alessandro. Hi, Alessandro. Oleg, we don't see you. Sahu and Igor and Sarah, maybe you will turn on your cameras too. And maybe Oksana, you will turn on your camera too. Oh, hi, Igor. Great, great. Okay, I see the smile on your face, guys. It is really good. So I think we are ready to start the common photo. Are you ready? In 3, 2, 1, and just smile. Okay, just a moment, I will save our photo. And the chance number 2, common photo. Oh, Oleg, beautiful background. Okay, 3, 2, 1, and just smile. Perfect. And one more photo for those who connected to us right now. 3, 2, 1, just smile. Great, great, perfect. Thank you, guys. Thank you for this friendly start. And now we will continue our webinar. So the best photo we have done. Okay, so one rule of our webinar. So if you have a question, we are really glad to answer for your questions. And please don't hesitate to ask us in the Zoom chat. We collect one type questions and answer on it during our webinar. We are open for your questions, guys. So today we would like to tell you more interesting information. First of all, we will start our story about us. Then we will tell about educational trajectory. Next, international community. Then webinar program overview, such as a Clover Drone, setup and pre-flight checks, difference between manual and autonomous flights. And in the finally, we will provide summing up of our webinar.
Svetlana, can you hide the top bar of Zoom because it's hiding a part of the presentation?
Oh, thank you, Timofey, but I'm not sure that I can do it. Just a moment. I will try to share my screen again. So this is better or no?
Can you, well, I don't think it is better. I think it's the same.
Okay, let's try again. Okay, maybe.
Yeah, now it's better. Yeah.
Yeah. Okay. Okay. Zoom has some surprises for us. Okay, so first of all, I would like to tell you about our company, Copter Express. We international company and we produce drones for industry and for education. For industry, we have a Pelican product line for air delivery, and Drone Point, it's a new solution to provide autonomous air delivery without couriers. And drones for education, it's a Clover. Clover Drone has an open source platform. It allows us to prepare new specialists in autonomous drones industry. So using Clover Drone, we have created the new system of education, which combined in the industry and educational organizations such as schools, colleges, universities. It allows us to provide training for students, for teachers, for young specialists, and show them how work with real task projects. This system allows us to motivate students, provide research activity, create new projects, and participate in the competitions, camp, and different type of trainings. Our competitions open for students starting from 12 years old, and we don't have the upper level age for it. We use, as I said before, open source platform for our educational products and for industrial products. It consists of flight controller on PX4 platform and onboard computer Raspberry Pi 4. It allows us to prepare students, to allow them to get new skills on educational equipment and be ready to work with real big drones, such as the industrial Pelican drones, because they have the same platform for such as a flight controller and platform for autonomous flights. So also Clover allows us to develop the skills such as assembly, flights, piloting, and programming as well. Now our international community consists of more than 2,000 members from 26 countries. This geography was extended due to our events, competitions, cooperations, and project developments. But also during the pandemic time, we teach and we save the international community using international online events such as camps or competitions or contests. So, for example, one of our first international events was collected participants from 14 countries. It was really great. So this is example of our workshops of our competition management center or our drone laboratories in universities, colleges, and schools. On this slide, you can see how it works in online. So for providing competition, we use a simulation environment, real venue, remote venue, and live stream for our participants. They can try to perform the task in the simulation and then try to perform it on the real drone. And this system allows us to to provide to recommend educational trajectory where we can start from using simulation environment. For example, for us, it's a gazebo. Then, when you have got the first programming skill, you can apply your gotten skill on the real drone, COEX Clover, and it allows you to get fundamental knowledge of drone programming. So the lessons and the introduction in gazebo simulation you can get from our previous webinar. The recording was saved on our website, and check it. And today we will give you the intro in practice on the real drone. And these basics will give you opportunity to create something new using open source technologies in Aerial Robotics area project. So this event where you can apply your skill and create something new. It can be any idea of your mind. This is a copter hack event, and this event allows you to open your talent and demonstrate it all over the world. We will open the registration of for new copter hack 2022. This registration will be open in the summer, in the middle of summer. So, but for now, also you can visit our open Gitbook and see about projects from our students who has took a part on the copter hack in different in the previous years. So this is examples of several projects, but we have a big library of open source projects, and you can use it such as a base for your projects. And also you can visit our official website and the page of education, and you can find all materials that we recommend for you. It consists of curriculums, textbooks, manuals, video tutorials, video webinars, and different presentation, of course. You can use it for your work with Clover Drone. Before we start our main part of our webinar, maybe you have any questions regarding the previous information. For me, you can ask by voice, or you can ask in the chat, in the Zoom chat. Prepare your questions, and I will answer on it. So, and before you prepare the questions, I will tell you about the plan of our webinar for today. So today, Timofey will tell you about how to upgrade the Clover drone for autonomous flights, how to provide the pre-flight checks, what is the difference between manual and autonomous flights, and how to check the first flight before you will run the program. And also the main and very important information, it's what you should do when something goes wrong. Yeah, because emergency cases sometimes happen, but we don't afraid it because we know how to work with these emergency cases. Okay, so I will be in Zoom and I will be open to your questions. So Timofey, I hope you are ready to start the interesting webinar. And
yes.
Okay, I give you word and thank you. Thank you all. We start to deep in drone programming and preparing autonomous flights. Let's go. Let's fly.
All right. So let's begin with what you should have prior to what we are going to learn today. First thing is you have to have an already assembled and proven to work Clover without Raspberry Pi. So I will show you how to install Raspberry Pi and how to make it work. But before that, we need to make sure you have at least a flying drone that can be controlled with your controller. And this is a drone that I have. So as you can see, it's already built. It has properly installed everything like motors, ESCs, flight controller, and it also has LED, but this will not work until we put Raspberry Pi on it. So we will start with testing whether this drone will even fly or not. So we need to make some pre-flight checks with this drone, and I will show you how to fly with the drone in manual mode. So for that, I will first connect the RC receiver with the RC controller. I need that to control the drone. And we will also check some settings in QGround control. This is a program that we use to work with flight controller. So let me begin with my screen first. By the way, those are 3 programs that we are going to use today. This is the Visual Studio Code, a program where we will write our programs for Clover. This is Balena Etcher, the program that we use to flash the SD card for the drone, for the Raspberry Pi. And this is the QGround control program. This is the program that I have already opened, but I will launch it again just to show you. All right, this is launching now. And it is disconnected from the drone. So what we need to do, we will find a micro USB output on the flight controller. I hope you can see it here.
No. Just a moment, Timofey. If you demonstrate something in the camera, please turn off your demonstrate.
Yes. Yeah. So this is the flight controller. This is a COEX PIX flight controller. And this is a micro USB output. And I will put this wire into the flight controller. So how to use this wire? Some people don't know how to properly use these types of wire. So don't you ever do it that way, please. Only stretch it from side to side without touching the middle part, because you may break it otherwise. So I will make it the longest length and connect it to my computer. In one side, let me check. Wait a second. I need to make a free USB spot. Okay, I will use another one. So I will connect it to my computer and the other part to the flight controller. Okay, I've connected them. Let's see what we have Okay, it's still, it says it's still disconnected. Sometimes it happens if you connect it to the wrong USB. So maybe we will just change the USB port that we are using and it will be connected this way. So I'm unplugging the wire from my computer and plugging it in another USB and wait for the keyboard control to detect the drone. Okay, now it is detected. If I press back here, it shows a map. And this map usually it indicates where you are located right now. On the right, you have these gauges that show you your tilt of the drone and your heading. And here I want to test some parameters in vehicle setup. So I press this purple button and go to vehicle setup, then radio. So I want to make sure that I connect radio correctly to the drone. And now I will turn on my radio controller. And as we can see, as I turned it on, there is nothing that indicates that it's turned on. It means that they are not bind together. So I need to bind the radio and the radio controller and the radio receiver. So how do I do that? Let me now turn off my screen just to show you how to do that. In camera. So in order to bind a receiver and the transmitter, I need to press bind key here before I turn on the controller. Then I turn it on and it says RX binding. Now I put it aside, and what do I do next is I find my receiver on the drone. As you can see, it is blinking red. It means that there is no, it doesn't detect the controller. So I need to turn off the drone. So I plug it out, and now it's turned off. As you can see, it's not blinking, nothing happens. And there is a small bind key, a small gray bind key here. I need to press this key, and after I press this key, I need to power on the drone, maybe by USB or by the battery. In this time, I will use my USB. So sometimes it's hard to press this small button, so I will use a tool just to press it until it clicks. Keep pressing and plug in the drone. I think I didn't press it hard enough, so it didn't bind for the first time. Let me do it again. So sometimes it is difficult to do from the first attempt. Let's try it again.
Timofey,
Yes.
maybe we will add camera from Oksana to demonstrate small details.
Well, maybe. Yeah, we can do that.
Or you have finished.
Not yet. I will ask Oksana to do this for me.
Yeah.
Let me just grab something from here. Yes. I will use another receiver just to demonstrate how to bind it, because the previous one has a hard to press key. So let me use my spare drone for that. Can you see what I'm doing right now? It's not so easy to remove the antenna.
We see.
Yeah, but we need to do it anyway.
Оксана, ты можешь чуть покрупнее, ну, Тимофея просто подснять? Ну, там
В
вот,
принципе, это не самая
или
важная
не
часть.
обязательно? Ну, ты
Да,
говори
это
просто,
сейчас не
что,
обязательно.
где лучше подснять.
Да. Мне пока ничего особенного не нужно делать. Да, пока можно выключить. So, I want to...
Только, Тимофей, мы тебя потеряли. Тимофей, we have lost you.
Oh, yeah,
Please
it's...
come back in the main
I'm still
camera.
here. Yeah, I know. I need to... for a moment, I need to go out of the camera because my tools are in another place. So you can see the Oksana video stream where I am unscrewing some screws. Yeah, and now I've got a RC receiver that I'm going to use. Okay, and let's bind it again. So Oksana, can you demonstrate the process? So this is the bind key. I will turn off and turn on again with first pressing bind key, then turn on the controller. It is RX binding, and now I press this little key with my nail. Yes, I pressed it, and now let's power on the drone.
Just a moment, Timofey. We don't have a video from Oksana.
Oksana, do you have video?
Yeah.
Can you check?
Now we have.
Okay, now you.
Соединение слабое.
Okay, now you see it. Okay, I will turn on the drone. Let's see. Yeah, it didn't bind again. I guess I need to press harder, or maybe something in the controller is not set up correctly. So let me use the other controller. I guess they should already be have been binded before, so they must work together. All right, I turn it off and press bind, and then turn it on. Okay, there are some technical problem. I think we will avoid wasting time on that. I will just use another drone that is already binded. Okay, yeah, now it's solved. So everything now is working. Yeah, I forgot to turn off and turn on the controller. Now it is binded, and we can test flight our drone. And Oksana, thank you for the video. I will now continue with my screen sharing. Okay, so what we have now. Can you see my screens, Svetlana and others?
Yeah, we have. We can see.
Yeah, okay. So the controller is constantly red, and now it's, the receiver is red, and now it should work. So let me disconnect and connect the drone. and reconnect to ground control. Wait for it to load. If it doesn't load from the first time, you can disconnect USB and connect it again. Let's undo it again. So this may happen to you as well. Sometimes you need to switch between different USBs until it finally detects the drone. All right, now it's connected. Let's go to vehicle setup and radio here. And as you can see, I can move my sticks around, and it will be shown here on these pitch, roll, and yaw bars. Sometimes they're not centered perfectly, but it should be okay for our test flight. Let's check the flight modes and then power. So first, let's check flight mode. We need to make sure we have set kill switch to work properly. So what is kill switch? Kill switch is the switch on the controller. I will show it on the camera. So kill switch, we usually use the SWA switch for that. It's a switch that you can click and the motors will stop rotating just to avoid if a drone hits something or unexpected movement. So it's very necessary to have kill switch set up correctly. Usually we use SWA, but it's up to you what to choose. I recommend you use it as in SWA. So in my RC controller, I need to set it in settings. So which channel works in which switch. So first of all, let's think of it. What if you had a brand new controller that wasn't set correctly before? So you need to go to the settings. If you hold OK button and open system setup with OK, scroll all the way down and open aux switches. Okay, here, sometimes some of them are turned off like that. I will just show you what if all of them were turned off. And the channels usually 8. Okay, this is kind of a basic what you get in the beginning. So I open aux switches again. And I click up to turn on all of the switches, then click OK to go to next. Okay, OK, OK, OK. And then I select the number of channels. So it may be either 6 or 8 in the beginning. So let's just have 8 for a little redundancy. We don't need all of them, but sometimes you might need them. And to save that, you hold cancel. And now it's saved. All right, now go back once again and go to press up and open function setup. Okay, then scroll to the aux channels. And let's change the channels numbers. So channel 5 will be SWA. So I click up to or down to switch between switches. So it's now SWA is channel 5. I click OK, and let's use SWC as channel 6. I'll scroll a little bit down. Okay, it's now C. If you want to have some more switches, you can press OK again. And for example, for channel 7, you can set SWB. that we didn't use yet. Okay, and SWD in the last one. And hold cancel. Cancel. All right. Now my controller is ready.
The best logic to save all settings, press and hold cancel. Not okay. Only cancel will help you to save all settings.
Yeah, hold cancel for saving. Then let's check what we have in Q ground control. I will demonstrate the Q ground control again. Okay, can you see that? Now, if I click my switches, you can see they change in here in flight modes menu. And here on the left part, we have mode switch. This is necessary to set to 3-positional switch. It's now channel 6, and we need to select channel 6 here, channel 6. And let's test what we have here. So it's switching between modes, but it's only switching between the 1st, 4th, and the 6th mode. It's okay because we have only 3 positions, but 6 are available. You need to make sure that only the positions you can select are set to some modes that you want to have. I usually either set stabilized position, stabilized, or stabilized position. I personally prefer the latter one. Stabilized position. Position flight mode is using aruco markers to hover on the same spot. Okay, we have set channel 6 to be a mode switch channel. But we also have channel 6 in kill switch, which is not correct. We need to set it to channel 5, I guess. Yes, I'm now switching the channel 5. It's SWA. And it's turning on and turning off kill switch. All right, now we are ready to proceed to power. Go to power.
In stabilized position, hello?
Hello?
I have a question one.
If it's quick, I can answer then.
Yeah,
go.
I need to know about the stabilized position. In stabilized position, is the drone going to be hold at a certain position or what?
All right, let me explain that. Stabilize will not hold position. It will just maintain horizontal position if you do not move your sticks. But it will not hold position at all. If, moreover, if you have calibrated the drone not perfectly, especially calibrated level horizon, without being horizontal, it will always move sideways or somewhere else instabilized. But this is an easy mode to fly, and I recommend to use it because this is the only option you get and only easy option you get without any external positioning system. Okay, I will explain it later in more detail. But now let's go to power.
Okay, thank you.
Yeah, okay, thanks. First, select the number of cells in battery. We have 3-cell battery. It's 3S. Let me show it in camera. So here is 3S. It means 3 sequential cells of battery. Here, let's go back to the ground control. Let's select 3. It's already 3. Then the empty battery voltage, we usually set it as 3.5. Then the full voltage, we use 4.2. I mean full cell voltage, not the battery voltage. And here is voltage divider, the option that almost everyone new to the drones skips, but I don't recommend you to skip that option. It's very, very important to be set correctly. So what is voltage divider? This is actually a number that you multiply your raw data from the flight controller, the raw voltage data from the power distribution board to flight controller, and it makes sure that the battery like the voltage is calibrated correctly. So if voltage divider is wrong, then you will have wrong voltage in flight controller. So it thinks it's either too much or too low. And 30.65 is always wrong. So if you keep it that way, it's always going to be a wrong voltage. And if I connect my battery to the drone, it will show something like 19 volts or 15 volts on freeze battery with this wrong voltage divider. So how do you calculate that? The most correct way is to check the actual battery voltage. Then, well, press calculate here, then I will show you what to do next. So let's warning, this is dangerous with propellers. So I'm going to connect the battery with propellers, but I know what I'm doing, but this is not safe. So just keep it in mind. I will show this on video and on video from my phone. Yeah, sorry for that. On video from my phone. How do I flip the camera? Yes. So what do I do? First, let's measure with the buzzer. This is a buzzer. It shows you the voltage of the battery and will buzz when the battery is discharged. So I will connect the buzzer that way. You see this red wire?
Oh, Timofey, could you rotate your phone to get?
Yes.
Yeah.
So here is,
mode.
yeah, there are three black and one red wire, and I will connect it that way. Let me show it. Let me connect it first, then I will show it to you. I connect it that way, and it shows me the voltage, the full voltage, and the voltage per cell. So the full voltage is 12.4, and then each cell has certain voltage. Now I know full battery voltage. Then I will connect the battery to the drone. Warning again, this is not safe. This is against the safety guidelines. So do not connect it on your desktop while propellers are on the motors. So I will connect the drone and show you. Okay, I have connected it that way. Now let's see what we have in P ground control. It says it's lost communication between the drone and the computer. Let me plug it again. I hope it will find the communication again. See. Okay, now, as you can see, it shows me 100% of the battery. But what if I click this icon? It says the voltage is 15.39, which is way too much than it's actually is. It's all because the voltage divider is by default is the wrong number. So we need to check it again. How many volts do we have here? It's all is 12.4, but it says it's 15.37. Let's go to the vehicle setup, power, and here we have voltage divider. Can you see it, or maybe it's too bright?
Oh, it's so bright. We can.
Yeah, I will
switch
back to. I will switch back to my screen.
Can you please share the screen?
It will be better.
All right, now you see, now you can see my screen, right?
Yeah, we see your screen.
Here, let's press calculate and put measured voltage in this field. The measured voltage is 12.44. Then press calculate once. All right, and press close. This is it. And now the voltage divider is almost 11, it's just about 11. And the most fun part is it's almost every time 11. So if you want to save you some time, you can just press 11 and check whether it shows the correct voltage. If it's not, then it's not 11. Sometimes it's 11.5, sometimes it's 10.5, but most of the time it's 11. So I can even round it to be 11 exactly, just to have a better number here. I will not calibrate ESCs now, and please do not do that while battery is connected. So I hope this drone is already ready to fly. And this is actually what I wanted to check before I fly. I will disconnect it from my PC and disconnect everything else. Now some pre-flight setup. Okay.
Timofey, if
yes.
you have finished with the Q-ground control, could you turn off the demonstration and switch on any camera where we can see you?
Okay. Yeah.
Okay, great, perfect.
So how do we fly the drone? First, let's make sure we have all the wires fastened, and so that they will not hit propellers. They will be broken by propellers. I have some wires that may be broken, so I may just tie them up for a moment. I will use them later. This is why I do that. I may use cable ties for that, but for now I don't need to fasten it forever, just for some moment. Let's do that. Okay, now this is already better than what it was before. What about them? You can put them in between the legs, like that. It may look funny, but this is better than not doing that. This is a temporary option. Okay.
Yeah, but
and
we recommend you, when you assemble the drone, you should keep strongly all wires and connectors. It allows you to get quality flight, and be sure that no wires will be cut by propellers.
Yeah, and now I want to connect. Connect the receiver. I want to fasten it with the cable tie. So this part actually needs to be set up properly. This is why I'm going to select a best place for that, and just put on some cable tie. Let me do it first, and I will show you what the position that I chosen. So okay, this is how I connected the receiver. And now, what do we do next? We take the battery with the buzzer and go to the flight zone, and make sure you turn off your controller before you turn on the drone. My controller is on, and now let's put the battery here. So let's make sure I have set the buzzer to buzz on certain voltage. So there's a button on top of that. You just click it and select. I recommend you selecting either 3.4 or 3.5. 3.5 will make the buzzer buzz earlier than the 3.4, but it will make me be sure that the battery is not discharged too much. How do I put it here? So I can place the battery that way, and the buzzer will be on top, and I will wrap it with this Velcro thing. So let me do that for you. So this is how it's now connected. Make sure it's not going to fall off from here. And now I can connect the connector, the power connector. All right. So now I have my controller, and let's test if it will even arm. So the drone is arming by putting the left stick to the bottom right position. And if I increase throttle,
Oh, it's fly.
I disarm the drone, and for safety, I will even press kill switch. And now I can grab my drone and proceed with.
Just a moment, Timofey.
Yes.
Could you demonstrate us what difference between disarm function and kill switch? So
Yes.
what is the dangerous if we will use only kill switch? I think it's a really important question because many of new users don't know about these differences, and sometimes it can be get to emergence case.
Yes. So kill switch will not disarm the drone. So how do we prove that? Let's arm the drone and put on some throttle. I'll kill switch that.
Yeah, unfortunately, we don't hear the sound of the noise from drone. But in this case, when Timofey provides the arming, propels starts rotate. Yeah.
So what I was doing right now, I armed the drone first, then I kill switched the drone, and it stopped rotating. But once I tune the kill switch off, it rotates again because it wasn't disarmed. So can you hold it again for me? So once again, I arm the drone, maybe increase some throttle and kill switch. It looks like it's not armed, but it's actually armed. And if you turn off the kill switch, so you need to kill switch it and disarm it. Then you can test for the rotation like that. Turn it on, off and on again. If it's not rotating, then it's disarmed and you can turn off the kill switch. So thank you for reminding me. This is very important to know. Okay, let's now let's go to mount the needed hardware on the drone.
Yeah, so our first part of webinar was finished. So we have checked the manual flight. The drone can be able to fly because it's really important before we start preparing for autonomous flight. And now Timofey will preparing drone, Clover drone for autonomous flights. Firstly, he will mount the Raspberry Pi and other functional elements. Then we will check our drone in position mode. And finally, we will write the program that allows us to provide the first autonomous flights on drone.
Yes. Okay, let's prepare the hardware, and let me first show you what article I'm going to use and you are going to use to know how to set everything up correctly. So let me now turn on my screen. Svetlana, you can switch to the screen.
Yeah. The screen will switch automatically.
Great. So let's go to the clover.coex.tech, enter, and open English website. and the assembly article. We will use Clover for assembly. I think this is the version that we have. I will scroll down to the part where we mount Raspberry Pi. Okay, installing Raspberry Pi. For now, I will not attach SD card. I will do it later. And we will attach the Raspberry Pi the way that's shown here. The BSC is an option that you can use for powering up your Raspberry Pi. Another option is to use the outputs from the power distribution board. This is what we are going to use on this drone. And this is how you connect the power to the Raspberry Pi. Okay, if you have a newer version of Clover, you may need to open the Clover 4.2 assembly article, because there are different versions of Clover and they vary depending on the version you have. Okay, let's start. Let's start preparing our hardware. So this is a Raspberry Pi, and it needs to be installed on the Clover. And let's find the right holes for that. So there should be certain holes that we are going to use for our Raspberry Pi. Let's see it in the article. Yeah, and here, this is in these instructions, there is used a deck, mounting deck before Raspberry Pi. Well, this is an option that you may want to use. I personally think this is not necessary to use exactly this type of mounting the Raspberry Pi. So you can connect it directly to the frame. But this version, I think it requires some deck. Let's see how it's here. Is in an assembly drone. There is this deck. So we need to have it. I think in my kit, this deck is missing. So we need to ask our organizers to bring it for me. So can I ask you for... можешь принести пластину для Raspberry, которая под вот это, без дырочек для камеры. Вот. Okay, so I'll ask to bring me this deck, and before I have it, I will show you what else you're gonna have. So this is the camera. I already attached this camera to the mounting deck of the camera. So this is how it looks. And this piece is attached with these screws, the small screws that you can put here in these holes. 2 screws is enough, but you may want to use all 4 of them. And the cable from here, make sure you do not bend it too much, and make sure you do not break it.
Could you repeat demonstration? So we turn off the screen sharing.
Yeah,
and
sure.
Demonstrate the full view of camera.
I wanted to show you that this is the deck, the camera, and connected to the certain deck that is used for camera. And you can screw it with small screws represented here. If you can see, there are black small screws. And this is one connected with 2 screws, but you may want to use all 4 of them. Yeah, let me see if this is the one that we want to have. Yes.
Yep.
Yeah. And then we also have a laser rangefinder. This is a laser rangefinder and 4 wires that we will use to connect laser rangefinder to Raspberry Pi. Then what you need to have prepared on the drone. First, you have to, depending on the version of Clover, in the recent versions, it's already the way that I'm going to show you. So on the power distribution board, there are 2 5-volt outputs right here. So this is the front part of the power distribution board. So as you can see, the back is here where the power wire is connected to, and the front part is here. And here on the bottom, as you can find 4 outputs, like one and the second, the first and the second 5-volt output, and they will be used for, one of them will be used for Raspberry Pi, and the other one is going to be used for LED strip. We have these 2 types of wires outputting from there. First type has this type of connector, and the other one has this type of connector. And make sure you do that, you solder them before you assemble the drone correctly, and assemble the drone fully, because it will be difficult for you to reach this place later on. This drone is already prepared for that. Now let's connect some wires. So those are wires.
And also I would like to add some information. Clover has can be in 2 types. So it can be such as a solder kit and such as a kit with connectors. So it means solderless. So in the second case, you don't need to provide some soldering operation, because all connectors will be soldered before. But if you have the previous version of Clover, you should, such Timofey said before, to provide some soldering operation to add connectors to get power for your Raspberry Pi and LED strip.
Yes, and what I just did is, on the LED strip, we have the ground, the plus, and the signal wire. So how do you know which one is which? This is very important. If you connect it the wrong way, it will not work. So there is an arrow on one side of the strip, and there is no arrow on the other side. So where the arrow is, you want to find where the tail of the arrow is and where the nose is. So the tail is in the right side and the nose is on the left side. And sometimes people may solder the wires to the wrong side. So some people may solder it to that side, which is closer to the head of the arrow, which is incorrect. The LED will not work that way. You need to solder it to the side where the tail of the arrow is, and the bottom connector is the ground. And this is the side where with the arrow. The top one is the plus. This is the side where there is no arrow, and the middle one is the signal. You will connect this to Raspberry Pi. Okay, I have connected the black wire from power distribution board, which is the ground, to the brown wire from the LED, and I connected red to the blue one from the LED, which represents the plus. And the signal is hanging here for now. It will be connected later. Now, what next should we do? Let's
Timothy,
find...
just a moment. So I repeat the important information. So arrow, bottom side, it's mean ground, top side, it's mean power, and center, it's mean signal. Yeah?
Yes.
Okay, great. Thank you.
So let me now check what length, the spacer of which length should be placed here. I will test it with another already assembled drone. So yeah, I have 2 lengths of spacers, even 3 of them. And I will use the one that's about 2 centimeters long. In the tutorial here, they should indicate which ones should we use. Well, I will not waste time searching for it, but just start assembling. So how do we connect them? Let's pick 4 of them and find the right holes for them. Yeah, and for doing that, we need to detach the top panel, the top deck, because otherwise I cannot reach with my screwdriver. So let me unscrew the top plate. The last one. And now I need to remove the wire from here. Okay. Now I have enough space to reach all the holes that I need. And I will screw the spacers in. I'll grab 4 screws. Let me see which ones should we use. Eight millimeters. So this is the one that I have. And I will first put the screw in the hole. Look where I put it here. So this is the back and this is the forward part of the drone. I have put my screw in the hole, and now I will place the spacer on top of the screw. I will do it by hand without fastening too hard because I might break the screw inside. I mean, I may break the spacer if I do it too hard. Another hole is very close to the RC receiver, which is why I will probably need to detach it from here for now and attach it later. So let me break the cable tie. Let me put in my screw. I'll do it from the top, then I will flip my drone. All right, I will hold it with the screwdriver and flip it right now and fasten it by hand. All right, the other side. Sometimes it's easy to connect it to the screwdriver first and then use the screwdriver to put the screw in. And fasten it. All right, and the last one. Okay, once I've done that, I will hold my spacers and fasten the screws a little bit more, not too much because it might break inside the spacers. Okay, this is enough. And on top of that, I will place the correct, where is that? Yeah, this is the deck that I'm going to use. There are two decks, one of them with the hole for the camera and another one without. So this is what I'm going to put on here. But I guess it asks in the instructions, yeah, it suggests us that we first put on that some screws and some spacers. So let's do that first. Let's see what we need to do. So in these holes, in these ones, we need to put some spacers on one side and screws on the other side. So spacers here, 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 and here, and small spacers on the closer to the middle part. Let's see what lengths of the spacers should we use. It's better, again, to compare with already assembled drone. This is the right length. I think it's 3 centimeters long. I'll grab 4 of them. And I will grab 4 screws. So very, very easy process. Again, by hand without fastening too hard. Because they are made of plastic and plastic might break because of the screw. And also 4 short spacers, these ones, and 4 more screws. Let's see, where do we put them? So some of them go here. Okay, I think those screws may be too long for this, for the spacers that short. And I will just check whether they will fit correctly on them. And if it's not, I will replace the screws. Yeah, the screws are too long because I cannot fully screw them in the spacer. The spacers are too short for the screw.
So, Timothy,
yes,
some question for you. So, when you will finish the assembling process, so we have not enough time maybe you try to describe all steps in assembly, because it's not difficult, but we should to move a part of image setup and flight controller setup.
Right, all right.
It will be
I get it.
important.
Yes, let me just pretend that we have screwed all the hardware here, and let me proceed with the connection of the Raspberry and everything else. So
okay.
I think you are smart enough to connect all the screws together using the tutorial. And now let me show you how to connect Raspberry Pi. So here's Raspberry Pi, and this is the pins that we are going to use for connection. So let's see, where do we connect the wire? It should be in the instructions. Where is that?
Yeah, you can screen share it. It allows us to get information about pins and spinouts, and then you will continue to mount it.
All right, I'm sharing the screen now, and this is how I connect the power to Raspberry Pi. As you can see, one pin is skipped. This is very important. So this is not the last two pins on the row. If you connect by a mistake this output, the power output to these two pins, it will burn your power distribution board, because those are two the plus V5 connectors. And let me show the Raspberry Pi pinout. Yeah, so as you can see, so those are two pins that we are connecting the power to, and those are the same V5 volts power pins that if we connect the ground with this to here and the plus to here, it will burn something, because this is a short circuit. Let's go back to the camera. Here we have here we have the plus, which is red. I will put it to the second from the side, and the ground will be just about it here. So first one is skipped, and then plus, and then minus. Is it clear? I hope so. So okay, this is more clear now.
Yeah, I think it's okay. So we see such as a second pin, it's a power, and next pin, it's ground.
Yes, and the next part is camera. Look at this camera. It has a wire, and on one part is a blue piece, and the other part is connectors. So where the connectors are should be on Raspberry Pi on the side which is more white. So the white side and the dark side. So I will connect the power side to this connector. So I need to pull it up a little bit, connect the wire, and pull it down and push it down. And now it's connected. So camera is connected. You can also find how to connect the laser rangefinder. So this is the laser rangefinder. It also has pins. So with these wires, you can find how to do that in the tutorial. Let's see if I can find it quickly. So for that, I will share you the screen. And let's open the programming article, and then laser rangefinder article. And here is a great picture that represents how you can connect laser rangefinder. So do it just like that. All right. What next? After you connect these things, you need to connect the Raspberry Pi with the flight controller. So you need this type of wire. It will be on the drone. And one side will go into these USB outputs. And the other side goes to the flight controller. So I'll put the wire in. And this is the way I do that. All right, so this drone is almost assembled. The final part is actually the LED strip. So this is the wire for the LED strip. This one goes into this connector. Let me show you. So this is closer to the USB part and closer to the right if you look at that way. So this is the corner connector from here. Okay, this drone is connected. Electronics of the drone is connected. I will actually use another drone for the further setup. So let me, in order to do that, let me prepare the next drone, which is, I guess, that drone. I'll put this one aside. So this drone is assembled the way I described you. Let's see, and let's find the controller for it. I'll test the drone for the controller. If I have one of those connected to the drone, it's a good news for me. Otherwise, I will need to. Bind a controller again. Yes. So let's open the key ground control and see if the drone is connected. No, it's not connected. I need to disconnect, close the key ground control, and open it again and connect it again.
Oh, Timofey, could you demonstrate us how you did connect it to Clover Drone via screen sharing, if it's possible?
Yes. So I just connected the USB. I showed you that already. And then the drone is now indicated here. I want to find the radio and test if I have any of my controllers bind. Yeah, I found a controller that's already binded to the drone. And now we can use it. So in order to perform autonomous flight, you need to have the correct firmware on the flight controller. So firmware is like software that's run on the flight controller. Now let's find the right firmware. I think we can now go to the screen sharing, and I will stop the video. Yes. I'll proceed with the screen sharing. So now, open the article, the configuration article here. Yeah, the configuration article. And here, the first thing is exactly the part with firmware. So flashing the flight controller. Prior to that, you might need to prepare your SD card. I have already prepared the SD card. I guess it's, if you have a flying drone, you already done that. So flash the controller with this firmware 1.8.2 Clover 13. Let's download that. So this is the firmware that we're going to use. Here in QGround, let's open the firmware option, and it says unplug and plug your USB. So I unplug the USB and plug it again. And here on the right, I need to select PX4, then advanced settings, then custom firmware file, and OK. And I'm going to proceed to the place where I've downloaded the firmware. By the way, if you just flash the controller, it will actually not, it will keep the previous settings of the flight controller, including calibrations. So if the drone did fly before, it will still be able to fly after I flash the controller. But I actually recommend you to have a brand new drone with brand new parameters. So now, as you can see, everything is ready to fly. But let me actually set up it from scratch. So I will press Tools, reset all to firmware's default, reset, and then again Tools, reset to vehicles default, reset. And now I will even firmware it once again because I want to have a clearest possible configuration and advanced settings here, custom firmware file, OK, and select the firmware that we are using here and open it. So I should have done it before I flashed it for the first time. So this is just, I'm doing the step one more time just to make it after I reset the settings. And we want to have a clear setup. All right, it's complete. Let's wait for it to load. All right. Let's choose airframe first. It's going to be generic quadcopter, but find COEX Clover 4 here in the list. Then apply and restart. Okay. Okay, then go to sensors and calibrate everything. In the COEX picks, you need to choose the correct rotation here. So instead of none, use the one that's roll 180 and yaw 90. Okay. Okay. And
Timofey, could you turn on your camera, and it will help us to watch how you will be rotate.
Yeah, I will do that. Let me turn off the sharing. So if I go to the QGround control, it asks me to, okay, I will recalibrate the compass again. So select compass. It's roll 180 and yaw 90. Okay, and then wait for it to become yellow. And now I will start rotation. Okay, wait for it to go green. It's taking too long for some reason. Yes, now it's green. And now I'll place the drone on its nose and rotate it that way. Wait for it to go green.
Is there any influence of the speed of rotation?
Not really. I just recommend you not going too quick, and if you make it 2 full turns, it's good.
Okay, thank you.
Yeah, now let's go to the screen sharing. It asks for reboot, so we can just press reboot and wait for it to load, and then proceed with the following sensors. So now it's gyroscope. Make sure you are not touching your table during that, and my drone is standing still without even moving and shaking. Press OK and wait for some seconds, and it will calibrate the gyroscope.
So it should be such as the ground without any shapeness and moveness of the drones.
Yeah,
It should be silence around the drone.
it's important to have. And now the accelerometer part, I think it's better to show it with the camera again. I'll ask my friend to do that for me again. So let me stop the screen sharing. Go to the Q ground. And here I will press OK. And then look at the screen. It's waiting. And it's initialized the horizontal position and it's completed. Then let's go to the position, this position, and I will place the drone the way it's not shaking, not moving. I hope so. Okay, the next one, the order doesn't matter. You can just flip your drone on each side and wait for it to indicate the correct position.
You can also demonstrate the screen and stay tuned on the camera. It allows us to watch your screen and small window with your camera view.
Yeah, let's do that. Yeah, and the last position is upside down. I hope it will not shake. Okay. It's not too bad if it's tilted a little bit, like a few degrees, it's okay in this calibration. But then when I go to level horizon, it's very important to keep the drone as horizontally as possible. So maybe we'll even need to put it on the ground. To do that, I will disconnect the drone from computer and make the wire a little bit longer, if it's possible. No, it's not possible. I will check whether it reaches the ground. Not really. Okay, I will calibrate it on the table. I hope the table is good enough for that calibration. Let me disconnect from the ground and connect the drone again.
So Timofey, the restart process will help us to save all settings and all sensors data which we have got during the calibration process.
Yeah, some calibration require a restart, but it's not too bad if you just keep restarting during the calibration. It still will work, but it's better to restart if it asks for. And now I will finally calibrate level horizon. Don't touch the table, don't touch the drone during that, and keep it as horizontal as possible.
Silence, don't move.
Yeah, it takes maybe 20 seconds to calibrate. And depending on how well you calibrate the level horizon will result in either stable horizontal flight, or it will go always to the side if it wasn't perfectly horizontal. So it will be harder for you to control the drone in stabilized flight mode. This is why it's very important to calibrate it correctly.
If the flight controller isn't mounted correctly,
Could you repeat your question, please? So louder.
if the flight controller is correctly not mounted, I mean somewhat bent.
Well, if you mount your flight controller with some tilt, or maybe it's has some angle to the drone with the drone, then it's not too bad. If you calibrate level horizon, it will cope with that problem. So level horizon will even go with that. I think it's done because it's not saying anything. And let's proceed with the following. I think now we can calibrate our radio. So I turn on my radio. As you can see, it's moving here when I move my sticks. And I'll press calibrate here. And what you see on the right is what you need to set your controller sticks. So I press calibrate, then okay, it says should zero your trims. So trims are actually the thing that, let me show it's on the camera. Svetlana, you see it's on camera.
So no, just a moment. Yeah. Yes, it will be better. Okay.
So the trimmers are those things, and they should be at 0 level. So on the bottom, you can see the trimmer indicator. It shows you how far away from the middle they are. And the sound is the best indicator for trimmers. If I, for example, go that way, it's higher. And you can see the bar has moved to the side. If I go back to the center, until the long beep, then it's centered. If I go right and left again, and it's long beep, and I know that's in the center. I will center out every trimmer here. Yes, they were not in the center, and now they are. So I zeroed the trimmers. And now let's continue with the screen. So I pressed here calibrate. Okay, and I place the sticks this way and press next. Then put my left up, then left down, then top, then bottom right and bottom left. Then I'll put my right, to the left, to the top, and to the down, to the bottom. And now I'll click once every stick I have, every switch I mean, and press next and next again. Well, it's I think it's calibrated now. And the drone is almost ready, but we need to set up the flight modes and the power thing. What about flight modes? Do you remember what we did with the controller before? We set switches to certain positions. And let's see what we have. Here we have channel 6, which is SWC in my case. It's correct, but what do we have here? It's altitude. I don't want to have altitude because I don't want to use barometer for my drone. So I do not use the altitude flight mode. I will replace it with stabilize. So I have stabilize in first, stabilize in fourth, and position of the 6. And how about kill switch? Kill switch is working on channel 5. It works perfectly.
Oh, Timofey,
and-
could you demonstrate how switch mode how flight modes switched by switcher? So, for example, you choose a flight mode by 2 position or 3 position switcher, and then you switch this position, and it will be highlighted by yellow.
I will do that later when I have my Raspberry Pi set up. After I set up the image on the Raspberry Pi.
Okay.
Then let's go to power and
May I know?
set it. Hello.
Yeah. May I know what does in that position mode do?
You will know that once I go to that. I will tell you about that. So let's first set the power. You remember that we have 3S battery with 3.5 the empty cell voltage and 4.2 the full cell voltage. And the voltage divider is 11, which is correct in this case. I will not calibrate the ESCs as it's already calibrated on my drone. And it's also dangerous, so don't do that if not necessary. And this should be it for the setup in Q-ground control. I will just quickly check what we have in parameters. Yeah, I see the parameters are correct. I will not explain what exactly I saw here, but it is kind of correct. If something, if I face some instabilities in flight, I will edit some parameters, and it may increase the stability of the flight. And now let me proceed with the image, the Clover image installation. An important, very important part. For Raspberry Pi, you need to install an operating system. And let's see, there is an article called Working with Raspberry Pi and the RPi image. Here you can find the link to download the image. It's about 4 gigabytes. And I have already downloaded the image. And you will need the Etcher program for that. This is the Etcher program. So I will use my micro SD card that's in Clover Kit. Let me show you on the camera to set it up. Okay, this is the adapter for micro SD card. And this is the SD card. I will open this box and take my SD card. Well, I think it's it may need some scissors or something like that to open. Be careful, do not break the SD card because it's easy to. All right, this is my micro SD card. I'll place it in the adapter and put adapter in the laptop. Okay. And now let's go to the screen. Everything that it's asking me for, just ignore that. Press cancel, okay, and close everything that's opened, and run Boolean Etcher. And make sure you removed every other flash, USB cards, and SD cards from your computer, because you may, for a mistake, erase everything on your other flash or SD card. So you need to flash from file here, select the file, and it automatically chooses some SD card or USB stick. Just make sure there is only one here. It's almost 60 gigs. select and press flash. It will take some time. I will ask for the password. Yeah. So we'll need. I will ask the password for the computer, and before I've done that, I will show you what next are you going to do. So after we flash the SD card, we will put it in the Raspberry Pi, and since that moment, we can now connect the power to the drone. So we will power the drone with the battery, and it should turn on the Raspberry Pi immediately, and it will take some time, but you will find a Wi-Fi network in here. So this Wi-Fi network is the Clover and some 4 digits. Yeah. I think, and I can retry. Flash and which password? Спасибо. Yeah, it started flashing. And I have prepared another SD card with already installed image. I will put it in my drone because it will take maybe 10 minutes or 5 minutes to load. But in order for us to not waste time for that, I will just show you how I connect everything to the drone. Let me switch to the camera here. This is the SD card with the image already installed. I will put this image in Raspberry Pi here. And now I can power on the Raspberry Pi. Before powering on, make sure you have this wire connecting the Raspberry Pi and the flight controller. So let me connect it. Yeah, everything seems okay. And now let's turn on the controller. It's important to do that before you turn on the drone. And you can even press kill switch just for safety reasons. Now let's select a battery and a buzzer. Find the buzzer to put in the battery in order for us to keep track of charge. So the buzzer is here. Yeah, the battery is full. And now I will go with that to the flight zone.
Timofey, while you go to the flight zone, so could you tell us what happens if battery will be empty, but you still fly on the drone?
Yeah, it's a very bad situation because lithium-ion batteries or lithium polymer batteries will die very soon after they discharge below a certain level. And this level is a little bit below than 3.5 volts per cell. If the battery is 3 cell, you need to make sure it doesn't go below 10.5 volts. If it does, then it started to break already. And if you discharge some cell below 3 volts, it may be even not charged back again. And you will just break the battery this way.
Moreover, you can create some fire if your
Yes.
battery will be broken. And in this time, when we have a low payload on the battery, for example, current, high current efficiency, it can be make the fire of battery and will be boom.
Yeah. If you short circuit your battery, it may heat that much that it will start to inflate and will pop and start burning and may even induce fire and explosion. So don't think that batteries are safe. They are not safe. Okay, now we have we can now check the Wi-Fi networks. Let's see if we have some. I have now Clover 5628. So this is the network that was just created from the Raspberry Pi, and I will connect to it. And it asks me for a PIN code, but there is no PIN code. There is actually only a normal password. So to do that, you click this link and enter the Clover Wi-Fi password. I will show you where to find it. Clover Clover Wi-Fi. And it looks like that, Clover Wi-Fi. Next. And it will say that there is no internet or no, the connection is broken, but make sure it's okay, because on Clover there is no internet. There's only internal network. So you can even, for now, you can close the window and open it again. And it says no connection to the internet, but it's secured at least. But you can actually connect to the Clover in your web browser. Go to the IP 192.168.11.1. It will bring you to the Clover server, and you can find documentation here, or you can find image topics and web terminal, everything you need to work with Clover. Is it clear? Yeah, everything is looking fine here. So, because when I connect to Wi-Fi, if Wi-Fi is the only way of I can connect to the internet, I will not be able to use normal websites. But now I have Ethernet cable connected to the laptop, which makes it possible to work with both Clover and internet. So here,
Timofey, could you
yes,
provide zoom in of this web page?
yes.
Yeah, thank you.
It shows me here the image version is 0 to 1 and 1. And let's see some image topics first, and open the image raw. Let's wait. It should load the camera in best case scenario. If it doesn't, maybe there is some problem. Sometimes certain browser will not load it because of some caching. I can test it in another browser. Let's switch to the Edge. Why isn't it not opening? Well, the Microsoft Edge doesn't seem to want me using it. I can just restart the Mozilla Firefox and test whether it will load image topics. Otherwise, it might be a problem with camera. Let's see. No, it's not loading. I guess it's it may be fixed after I restart the drone. So I'll just disconnect the power connector and connect it back again. I will also see if anything is wrong with the cable. It seems fine for now. Let's see. So the camera is actually the first thing that should work, and it will indicate that everything is working correctly. Let me close it for now. So Wi-Fi network, after I restart the Clover, the Wi-Fi network is also restarted, so I'll need to connect to it again. And let's see. Okay, let's go to the website. Launch topics and image roll. Yeah, now you can see that there is image. In this image, you can, well, the image is even very good and good quality and sharp, but sometimes the image may be blurred. For example, you just installed a camera and it's blurred because the lens wasn't set correctly. For example, here you can see it's becoming blurred. The reason for that is that...
Just a moment, Timofey, very important thing. So zoom in this view, please. Yeah. And demonstrate us the focus of camera.
So yeah, it's out of focus, that's for sure. And in order to put it back to focus, you need to rotate the lens of the camera. It may be not so easy if it's inside, in between the two plates, but I will try to. I guess it's the wrong direction. So some lenses will be out of focus. You need to make sure they are in focus. All right, it seems better now. Let me show it on the camera, how I did that. You see the lens here. This part can be rotated, it can be screwed. It's like a screw, it may be screwed down and up, and it will change the focus of the lens. So I did rotate it, and it helped me increase or decrease the sharpness of the image. Okay, what next? Well, we are almost done here. We need to set up the drone in its image. All right, so how do we set up the drone? First, let's go to the programming article and open the fiducial markers aruco and map-based navigation. So this is the only article that you need to find the necessary parameters for your drone to fly with aruco markers. And the configurations here, you can find what you need to change in order to make it work. It requires some knowledge of command line in Linux, and I hope you do have this knowledge. I did some webinars about that. And let's go to our terminal. Open the web terminal here. The password is Raspberry. I will write it again. Raspberry. So this is how you write the password. And we need to change parameters that are located in the Catkin WSSLC Clover launch directory. Let's change the directory with the command cd. C8 tab, S tab, C tab, C tab, then /L tab, enter, and then nano clover.launch. So what do we do here? In the article, it asks me to change the file clover.launch and enable the aruco markers from there. So I will open I have opened the Clover launch here, and I will go to the line that shows the aruco, and I'll change it to true. All right, then we can also enable blocks if we wanted to. So just if we wanted to program the drone with block programming instead of Python, we can do that. This is it for this file. Press CTRL+X. Then it asks me whether I want to save or not. I want to save. Press Y. And then the name, Clover Launch. I want to keep it the same, so I press Enter. Otherwise, I could just erase the name here and change it, but I just want to press Enter. Then we need to open Nano, then aruco.launch. And here what we need to do is look at the article and find what we need to change. So aruco detect, aruco map, and aruco VPE must be on. So those three parameters must be on. Only one of them is on by default. Yes, and we will actually create our custom aruco map. I didn't create it yet, but I will as the next part. And here in this line, we will provide the path to the map that we are going to use. By default, this map is called text map.txt. I will use the name maybe map2.txt, and this file is not created yet. I just do it in advance. Press CTRL+X, then Y, then Enter, and let's check what next. So marker map definition. Well, there is another. If I press LS, it shows me the list of files in this directory. And there is a main camera.launch file that we didn't set up in this time, but you may need that if you have a custom camera setup. For example, if you have put the camera on other side or in other direction, you will need to open the main camera.launch. For now, we will not change anything here, but if you have changed the direction of your camera, you can find what direction is correct by typing either camera is facing down or upwards, and whether the cable going backward or forward. In our case, let me show it on camera. The cable from camera, like look at this.
Could you, yeah, thank you.
The cable from camera,
Just a moment, Timothy, just a moment.
Yes.
Yeah. Okay, please continue.
So this is the front part of the drone. This is the rear part. And the cable from camera, this white and blue thing, is going to the back of the drone. It's facing back of the drone. It doesn't matter where exactly you locate your camera. It may be mounted here instead of here. But if the cable is pointing down, I mean back, then you select the backward parameter. Otherwise, you use forward parameter. So let me go back to the screen. So it's backward. If you are more advanced, you may know how to position your camera relative to the drone. You may even want to change this shift of the camera in 3 dimensions, X, Y, and Z. But by default, it's okay, so you might just keep it blank that way. CTRL+X. Then let's go here and create our custom marker map. So to create your custom marker map, there is a file, a text file. This is the result of your map creation. And this text file has, well, this is the example of text file that you will have. And this is actually the map I prepared in advance for you. I will show you how exactly I did that with my phone. Let me, oh, you hear that sound? It's because the Clover's motors were not spinning for more than 10 minutes. And it started to buzz the motors for us to know that it's still on and it's still working. And we need to pay attention to it and turn on the motors for a second in order for it to stop doing that noise. So I just arm the drone. It doesn't want to arm. Well, there's some error in the flight controller. Well, the only way for now is to turn off the drone. Let me do that.
Yeah, guys, and very important moment that you should to provide all flight operations only in the flight zone. So don't use don't arm your drone on the table or near other people because it's a safety rules. You should move your drone into flight zone and then provide arm and flights.
All right. What about the field that we have? First, let's see what do we have. So there are some markers. Those two markers are kind of out of all the field, and I will just not use them. It will be easier for me.
Timothy, one moment, please. Could you move your camera slowly? It allows us to have a good quality of the video view. All
right. So this is the map. I will pretend that there are no those markers. Each marker has its individual number. For example, this marker has the number of 86, and this marker has number of 82. It's recommended for you to put your markers in the correct order. For example, if we start from this one, it will be 0, then 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. You may start from a higher number, for example, 100, 101, 102. But this field was assembled without any order. So those are random numbers, which makes it harder for you to set up and for me as well. But it's still possible. And we need to measure, we take some measures of the field with, for example, ruler. And the first most important measure is how many rows and how many columns of markers do we have. So in this case, we have, this is going to be a 0 point. The point from where all the axes are going. So 0, 0, 0, XYZ is going to be just in this, in the center of this marker. The X will go that way, the Y will go that way, and the Z will go up. And how many markers do we have in X-axis? We have 3 markers, 1, 2, 3. It means we have 3 columns of markers. Then how many rows of markers do we have? Well, it's easy to count. 1, 2, 3, 4, 5. It's 5. Wait a second. I see someone's picture for some reason.
Yeah, so it's a really important thing. So when you equip your flight zone, you have a kit of Aruco map with the order of numbers. For example, you're starting from 10, then 11, 12, 13, 14, and up to 20. So you have 10 markers in the Clover kit. So it allows you to equip your flight zone with the aruco markers using the order of number of aruco ID. So it allows you to get a quick to create a quick map in your drone. But in this case, this map was prepared for different competition. It's one, and that is why one of the tasks for competitors, it's create this aruco map in the image, in the Clover image, and it has some difficulties for them, and that is why Timofey described all steps of creation it.
Yeah, so this map is made difficult on purpose. But for you to simplify the process, you just need to follow the order. From top left, you start with the lowest value, then go to the right. When you finish with this row, go to the next row with the next number, and so on. And what is the distance between the markers? The distance is measured between centers of the markers. Otherwise, you can measure it between, let me show you between which parts of the markers. So here we have, we can compare centers of the marker. So this one is here in the center, and this one is here. So I see like 97 centimeters. I think it's, I should round it to 100 centimeters because it was supposed to be. But you can measure it from actually a side of a marker, like here. It's now on a side of black box around the marker. And I compare it to the same side of another marker. So this side compared to this side, it's easier for me to check it that way. So the distance between the markers is 1 meter in x-axis, and it should be 1 meter in y-axis as well. So I compare it to the side from there, and here we have, well, 97 centimeters. Again, well, maybe this whole field is 97 centimeters by 97 centimeters. I will just double check it. Well, now it's 100. Okay, let's pretend it to be 100 for the rest of the field. And yeah, the rest. Also, we need to know the size of each marker. The size is the distance from here to here, and it is 22 centimeters. Okay, let's go. Let's turn on the drone, and we will generate the field. I'll do it on my screen now. And again, map-based navigation article. Let's open the terminal. It's now it's closed. We will need to update it once we connect to the Clover. I think it's already updated. Yes, the password, the Raspberry password here. And I will enter the command. This command, I will edit it once I enter. And to enter here, you need to use the Control-Shift-V, not Control-V, but Control-Shift-V. And the map that I want to create is going to be called map 2. Do you remember that? So the last part of the command is actually the name, the path and the name of the file that we are going to create. And here, from here, we will need to enter the values. So first value is the size of the marker. Let me show it to you. So length, so this is the length parameter. It's 22 centimeters, which is 0.22 meters. Here, 0.22 meters. Then the number of columns, it's 3. Then the number of rows is 5. Then the distance between markers in x-axis and the distance between markers in y-axis. So distance between columns and distance between rows, between centers of them. And then the first marker number. The number of first marker, I can keep it 0 because anyway, I will replace all the numbers with my own numbers. So for now, it will create the whole map starting from the marker number 0. And this map is going to be called map 2, and its path is Katkin WSSRC Clover aruco.pose map and map2.txt. Enter. And now I'll go to Katkin WSSRC Clover aruco.pose map. And then, and here I will open, first let me see the list of all the files here. Here is map and map2.txt, and so I'll open map2.txt, and as you can see, it has created a file. This is the file that is describing the aruco marker field for us. So let's start to replace the numbers with what we want to have. I have a drawing where with all the numbers of the markers. Let me show it to the camera. This is the drawing that made for me to more easy set up the marker field. I will use these values and place them instead of what we have by default. So instead of 0, I will put 76. Oh, sorry, 76. Then 78. Then 77. This is the top row. Then the second row. 83. Then 87. And 84. So I could just create a normal marker map with correct order, and I wouldn't need to do that. But as I have this field, I'll have to do it that way. 80, then 81, then 67, then 86.
Timofey, while you provide the aruco map ordering, so
Yeah.
could you tell us about plan for preparing autonomous flight? So first of all, we provide the assembly. Then we set up the flight controller. Now we provide the Clover Image setting, yeah. And so now we at the stage of the creating aruco map. This is our coordinates map for providing autonomous flight. So what steps we should to do next?
Okay, first let me save the changes here. What next? We will check the position flight mode, and then we will test our first program. I will show you how to prepare the drone and your controller for running the first program. And we will learn how to overtake the control over the drone if in case of emergency situations.
Oh, great.
And this is going to be it.
Yeah, great, perfect.
Okay, now as we have created the map, it isn't yet applied. So if we go to the image topics, wait a second, it's not loading for some reason. Well, It's probably because of some error. I probably have made an error. So let me just sudo systemctl restart Clover. I guess it's because I used map2.txt before I even created that. And now, after sudo systemctl restarts Clover, it will restart the Clover services. And it will probably run the image topics for me. Yes, now it's running. And after any settings in the configuration, you need to use this command, sudo systemctl restart Clover. And now we can find the aruco map image snapshot. And this is the map that we have created. It is correct. Well, it looks correct. And now we can even open the aruco map debug. And I will ask my partner to pick up the Clover.
Oh, and could you zoom in the camera view in browser? Yeah.
Yes. Можешь вот на этот маркер посмотреть, Clover? Yes, so as you can see, the X is red and the Y is green, then Z is blue. So this is the coordinate system of Clover, of aruco map frame ID. Спасибо, можешь положить. Yes, and now let me show you how to test the drone before flying. You need to connect to Raspberry Pi, to the flight controller. And there is an article called "In Working with Raspberry Pi, Remote Using Ground Control over Wi-Fi." Yes. This article describes how we can use key ground control when we are connected with Wi-Fi. So everything is already set up the right way, so you don't need to do that, but you just need to enter these parameters in creation of this link. So I open key ground control here, press back and disconnect from my previous connection. Then I will press this purple button and application settings. Then com links, and you should not have this pre-installed link. I will add a new one. Well, you can keep it unnamed and choose type TCP. Then the host address is 192.168.11.1. Keep TCP port the same and press OK. This is the one that I've created right now, and press connect. Press back and it says it's not ready for some reason. No bar sensor 0. Well, it says that there is no bar sensor, which is okay, and it's probably not going to arm because of that. Let me check that. So I will try to arm. No, it's not arming. I think it's okay. Yeah, I think I will need to edit these settings here, vehicle setup and parameters. And here I will use sys as borrow and put it to 0. It will disable the barometer. Okay. Clear. And I will even here parameters, tools, reboot vehicle. Okay. Let's wait for it to reboot. Sometimes this problem might occur because barometers on some versions of PIX, COEX PIX, there is barometer. On some, there is no barometer. And I hope this is the only error that caused this problem. We will check whether it's going to arm or not. Yeah, now it is arming, which is great. But I need to go back here and connect again. Application settings, comlinks, select this one and connect. You only need to set it up once, then it's already here. And now it's ready to fly. So we have the battery level, everything we need. And let me check the flight modes. So it's position, stabilize, stabilize. I can even switch to position here. And I will show you what is position flight mode. If everything is set correctly, after I go to the position flight mode, the drone will hover in one spot. Wait, I need to disable the screen sharing here so you can see it clearly. Yes, and in order to switch to position flight mode, I will place the SWC to the bottom position. And as you can see, the drone is changing its color. The LED in stabilize is green or something cyan color, and this is more blue. So I will take off in normal mode, then switch to position flight mode. And this is very important. Before you switch to position, or just when you switch to position, you need to put your throttle level right in the middle of the stick, because otherwise it will decrease its height or maybe increase its height. So this middle position in position flight mode indicates that the drone should maintain its height without ascending or descending. So let me show you how I switch between the modes. So take off first. Hover over markers, and then I'll switch to position flight mode and put it to the center. And now the drone is hovering by itself. So I'm not trying to maintain its position. It's already doing it for me. But I can control the drone. I, for example, may want to go to the left or to rotate. Maybe increase the height or go down. So this was the position flight mode. If everything is working in position flight mode, then you are ready to run a program. The program will run.
Oh, Timofey, thank you. Thank you very much for the position demonstration mode. So, and also we have a question about, could you explain all flight modes or maybe very important flight modes? So,
okay, I will do that.
Okay, thank you.
Let me open the list of modes. Can you see it?
Yeah,
we
see.
Well, yeah. So first, flight mode is manual. This mode is not working with drones, so you cannot control drone in manual flight mode. It will actually the manual flight mode is where you control the speed of each motor by your stick, but you are not a flight controller to control it that precisely, because the drone will just fly unexpectedly. So the manual flight mode is not allowed for us. So it will even not work. It will switch to stabilized every time. Why don't you want to use manual? It's only used for airplanes, I guess. Airplanes are okay to work with manual flight mode because they're more stable. So the drone is unstable machine, but the airplane is stable. The altitude flight mode is the mode that maintains the altitude, well, the height of the flight by barometer. So if you have a barometer on the drone, the altitude flight mode is available for you. So the center, the throttle and the center will make the drone hover on each height. If you increase the throttle, it will ascend, and if you decrease, it will descend. The position flight mode you just saw, it will maintain the position using some external positioning system like Vision, what we have now. The mission flight mode is the one that is used in mission mode. If you plan your mission with this menu, like adding some points, I'm not a pro of that actually. So there is some way to create new points. So you can make a path. It's used for GPS flight, basically. The next one is hold flight mode. I don't know exactly what it is. Maybe it's the same as altitude. I don't know. Maybe this is the same as position, but it was GPS. The return flight mode, it turns automatically when the drone is in the return. When the drone wants to return to home, it's also a mission way. It happens in missions. For example, if something happens to the drone and it wants, if something is broken, it goes into return flight mode and it is returning to the place where it took off. The acro flight mode is the mode that is used for FPV races and FPV cinematic shooting. Well, the Clover is not a drone that is good for acro mode, so don't use that. Use it only on racing drones. Wait a second, I think my connection has broken. Did it? Well, hello?
Yeah, thank you, Timofey. So we have a request for demonstrating acro mode, but acro mode, it's a topic of a separate webinar. So you can leave your suggestions and maybe interesting topics for you in the feedback form that I have sent in the Zoom chat. And we will prepare this material for the next webinar.
Okay, well, I have a problem with my computer. I will quickly go back to the Zoom once I enter all the numbers.
And Timofey, while you repair your computer,
Yeah.
so we have interesting question. So from Ashutosh, so they have a problem about that Clover doesn't hold the position in the position mode, and they have tried provide many number of calibration, but it's not solved this problem. So maybe you know any other solution that you can suggest them?
I think it's maybe because of wrong Raspberry Pi settings. So maybe you have set up incorrectly something, and but you can run the self-check.py to test whether everything is okay, and it will show you the if there is some problems. So Tala, can you make my computer a host, a co-host?
Yes, sure. Just a moment. Yeah, and also, Shutosh, we advise you to rewrite the image, repeat all steps which was demonstrated on this webinar. So, and also check the Aruco map field. Maybe some wrongs happens because of you have errors in the aruco.launch file.
Yeah.
Yes, it can be. So in any way, please write us in the support group, and our community will help you.
Yeah, let me show you. There's an article called Automated Self-Checks, and there's a comment that you enter It will show you if there's some errors. Let me show you how it works. So if I enter this comment, run clover self-check.py, it will run all the self-checks, and the sum of the checks will indicate, oh, good. Yeah, this is not good. Well, it probably will require a firmware reinstallation. So I will need to flash my flight controller again, I guess, because of that. Well, it's not critical. As you can see, it flies, but it's not good to have. Well, anyway, it showed me some really great number of errors. You will probably have not that much, but make sure that the camera is working. So this one shows rangefinder, the CPU usage, the aruco markers, positions and something like that, and some other things. So use that. All right, what next? We have checked the flight mode, and now let's write a program. So I will press CD enter, and this is the user, the folder.
So Timothy, one more question. So if we provide the self-check, as you showed before, so if we don't see any red strings, it's okay?
Well,
no?
Not exactly. Sometimes even seeing some, I mean, yellow, right? Yellow strings can be okay. For example, aruco markers, no map detection. It's just because the drone in this moment does not see markers. If I put it up so it can see markers, this will be white. For example, vision is the same. It's because there's no markers in the field. So those are not good, but as you can see, yeah, it's just because, probably because of some incorrect installation of firmware. Maybe I will need to flash it again and erase all the settings. All right, what next? Let's create a program. To do that, wait a second. My Zoom just crashed again. Maybe it's because Ethernet cable. Okay, let's see. Yeah, now it's okay. We can open the article called programming.
Okay, Timothy, but also we don't see you.
Me?
Because you, we don't see you because you have to turn off your cameras.
In the programming article, there is an example program. Let me copy this program and edit it in Visual Studio Code. So here, let's open the Visual Studio Code. I recommend you to create a folder where you store all your programs. Press File, Open Folder, and let's choose one. It can be even on the desktop. So create a folder, go codes, and select this. And now on the left, I can create file. I will name it one.py. And here, Control V, this is my program. So I will check whether it flies a path. It takes off here. The height is, let's have it 1.2 instead. Then maybe 4 seconds instead of 3. Then we go to the X0, Y0, Z 1.2. Then sleep for 3 seconds, and I will
Timothy,
make.
for
Yes.
example, when I don't have the Visual Studio Code on my laptop, and I don't want to install this program. So can I use, for example, web version of Butterfly terminal, or maybe other SSH clients such as a PuTTY?
Yeah, sure. You can create a program right in the web terminal. For example, if I want to say nano2.py, and I can Control-Shift-V the whole code or parts of the code here, it will work. But Visual Studio Code provides you with some more advanced code editing features, and they are good to have. So this is just a text editor. It will not do much for you. It will not detect errors, and so it will not autocomplete the code. It only highlights some of the values, but nothing more. This is why I will not save this file. I will first edit it in Visual Studio Code, and let's run a small square. 2 meters, and then 2 meters here, and 2 meters here, then 2 meters here, and 0 here, and then 0 and 0. And the time, I think 3 seconds is too little. I'd have 5.
What is this program will do?
This program will fly a square, but first I will also need to change body here to the Aruco map. Yes, and now it will fly a square, then land in the place where it took off. I will save this program, then copy this program and paste it here, nano1.py, Control-Shift-V, and this is the program. If you miss the beginning of it, you just scroll up and it's appearing here. Control-X, Y, Enter. And let me check the battery level. I can just make a ROS service call /get telemetry. I press tab and tab again. Keep it blank, press enter. And the voltage is 11.76, which is okay for 1 or 2 flights. Otherwise, I could watch it on the buzzer. And now I will show you how to prepare your controller for the flight. I'll disable the video from here and probably the screen sharing. So I will type the Python then 1.py, but I will not press enter. For now, I will turn on my camera on the phone.
Oh, Timofey, just a moment, one question. So what about speed of drone flight? So what is the default speed for autonomous flight?
The default speed is 0.5 meters per second. So half meter per second. So
for example, if we don't know, we don't write the speedy for drone, the default speedy will be 0.5 meters per second. Yeah, that's correct. Okay, thank you. Okay, now let me show you what I need to do in order to prepare the flight. So look at my phone. Here, I need to be ready in any moment to take controls. But if the drone is flying autonomously, it will not, sticks will not affect anyhow the flight of the drone.
In order to make it, in order to take control, you need to switch this SWC switch to any other position. This is why I set it to the middle position, which is already stabilized. But once I hit enter in the program, the drone will turn into the off-board flight mode. This is the mode that I didn't have opportunity to tell you about. I will soon. And once it is in off-board, it doesn't listen to my flight controls. So in order to take control, I will switch SWC up. And now, since this moment, I am controlling the drone. And make sure your throttle is not in the bottom position, because once I take the control, it will lower the throttle to 0 and the drone will fall. I need to keep it around the center. Well, and in the position where it's hovering. And now I set the switch to the middle position here. This one is in the middle position. And it's also a good idea to check the position flight mode before you run the program. I just checked that and it worked. It means that I can test the program now. So I keep my controller.
Hello.
Hello. Yes. What is your question?
Could you repeat once again?
What? Repeat what?
Yeah. If the program does not run, then how to take control over the drone?
Yeah. To take control over the drone, you need to switch the flight mode from anyone to anyone. Just hit your SWC, and now you're controlling the drone.
Покажите чуть крупнее пульт.
So I usually put it in the middle position, and to take control, I hit it up, and now I'm controlling the drone. This is it.
Okay.
Yeah,
The
so
throttles would
you
be at
you can
50%.
interrupt the autonomous flight when you switch your flight modes in any mode. So it can be stabilized, position, altitude, or other mode. But we recommend you use stabilized and position, because when you switch from position to stabilize, you can control drone by manual, and it's a simple mode without any surprises. It don't influence from other sensors such as the barometer or other.
Yes, and I don't really recommend you to use position to switch to position flight mode, because sometimes if you have a field installed incorrectly, it will cause the crash. So if I switch to the position on the wrong field, the drone may want to fly away on high speed. So this is not good. This is why I always recommend using stabilized for taking control. All right, let's now look at the drone. It is standing in the 0 position, and now it is pointing its head towards the y-axis. But this is actually not the way it's going to fly later. Let me do that. So once it takes off, it will rotate 90 degrees clockwise, because the default rotation of the drone is towards x-axis, which is going there.
Timofey, could you show us into flight zone? Because when you describe it, when you explain it, we can't see how drone, what orientation of the drone. So you can move drone if it's possible. It will be convenient for us.
Yes. So this is the camera. It's usually in the front of the drone, and I will put it that way, and it's heading towards the y-axis. But once it takes off, it will, after it takes off here, it will rotate 90 degrees, and the face will going towards the x-axis. It's okay. Just keep it in mind that every time, if you do not provide any other rotation, it will by default head towards x-axis. And now I will run the program. I don't know how it will behave. This is why I'm always ready to take the control. And I will hit enter. The command is Python space 1.py. And
no. Just a moment, Timofey. Could please share your screen? Show us how you.
I did it already.
How you will run the program, and then stop sharing.
Yeah, I actually showed it already. So I typed Python, then spacebar, then 1.py, and I'm ready to press enter. So I will stop the screen sharing, and I will press enter, but you will see the camera view. So 3, 2, 1, I press enter.
Let's fly.
It takes off. It is rotating, and it is going to 2 meters to Y, then 2 meters to X, and then it goes back to Y. All right.
Great, perfect. It's work.
Yes, and you see the purple LED indication. It means that the drone is in off-board flight mode. So it will not. I cannot even arm the drone that way because it's not in the correct flight mode. So whatever I do, it will not work. Only the kill switch will work. In order to take the control, I need to switch the SWC, and now I can arm the drone. Okay, this is working. And now what I wanted to show you is the emergency overtake the control. So let me show you how to do that. So first of all, I will share my screen, and let's pretend that someone sent you a program. Somebody sent you a program and said, check this out, there is something wrong with it. And you are lazy and you don't want to go into the code, and you remember that there is some problem with the program. You need to be ready to take the control any moment. And in this program, for example, let me create a program with some error. So, for example, somebody used, instead of 1.2 meters Z, they used maybe 4.2 meters, which is too high for this film. And it means that, oh, and even the speed is going to be 1, which is higher than the default. So this is the error. Don't do that. I will save. I will save this, and I will.
Hello.
Yes.
If we need to decrease the speed of the drone, then we should write 0.5 or something.
Increase or decrease?
Decrease.
Well, the 0.5 is already the default value. You can decrease it to 0.2 if you wanted. So just press just write speed equals 0.2 or 1 or something what you want. Okay, this is the program with the error. I save it.
Just a moment, Timofey. Could you?
Yes.
Could you? I am afraid that our users then when they will show the program. So could you write in the maybe comments or in the program about this program with errors? Don't repeat it on the screen. Yeah, thank you. Yeah, guys. So be carefully, and also each time you should understand what you will expect of behavior from your drone. because it's really important. And in this case, you can save drone, yourself, and other people who around you.
All right. I am ready to test this. I will turn on the demonstration and turn on the camera. Okay, so once it's doing something weird, I will take the control and land the drone. But I need to keep in mind the direction where the head is heading. So I remember that it's going to head that way. This is important because if I think it's directed that way, I go to left and it's going to there, not the way that I wanted to. So let's write Python 2.py and enter. All right, it takes off. Look. Okay, I need to take control. Okay, I'm landing the drone myself. Okay, this is how I did it. But I also need to press Ctrl+C immediately in the program and kill switch on the drone. So I kill switch the drone and press Ctrl+C. Because
Timofey, could you share in the screen? It's important that we should know what strings, what commands that program was interrupted, and the terminal described us.
Let me show you that. Yes. Wait a second. Where is the zoom?
Yeah, so you can see the errors. These errors of interruption from the two sides. Firstly, Timofey switched the flight mode from first position to second position, for example, from position to stabilized mode. And secondly, it's a result of pressing to hot command, Ctrl+X, yeah, or plus C, yeah, Ctrl+C, yeah.
So this will hopefully break the program. If the program does not stop after pressing Ctrl+C several times, sometimes you need to press Ctrl+C and press Enter. And if that's not working, then you can press Ctrl+Z, which is not recommended because it will not stop the program. It will just put it on a pause. But in case you don't know, there's nothing left to do, you can press Ctrl+Z and it will stop the program, but not completely. Okay, I think this is the most of what I wanted to tell you today. If you have some questions, I can answer them.
Yeah, we have one question about how to calibrate flight controller, the best method of it. So could you advise? It's the question from Zoom chat. So please let us know best method to achieve appropriate calibration of flight controller.
Well, I showed you a decent method for that. I personally do it that way, and it's usually fine. So I recommend you, if you want the same results, you may want to do it the way I do.
Could you show the connection between the power distribution board and the flight controller?
Again, can you?
Could you show the connection between the power distribution board and flight controller?
Why do you want to solder that?
No, I mean the connection, where to do, how to do.
Okay, Let me show you the connection. Maybe I will answer the question, but I don't really understand what you are asking for. I will show you the real drone and the way it is connected right now, the flight controller and the power distribution board. Let me stop the screen and all right. Very important to connect it to the right input. So in this type of flight controller, there is a back side of it. This is the front. And the wire going to this connector, which is closer to the back, it is actually identical to this one. But if you put it here, it may cause a lot of problems. So put it only here. And the connection is two-way cable, this type of cable. And this is the way it connected. It is connected to the power distribution board, the same output. So it is a good working cable. If you break this green or yellow wires, you will not be able to know the voltage of your battery in flight controller. So the flight controller, when you in ground control, for example, if you want to know the voltage, it will not be available because these two wires receive information. And two blacks are actually the same. This is the ground. Two reds are the +5 volts. This is it about the connection.
Can you remove the flight controller and below that I need to see?
Well, if you want it, but it will take some time. While I'm doing that, you can ask other questions. So, are there any other questions?
Timofey, we don't see you.
Yeah, I know that because I put my phone to the table.
Yeah, we have a question, another question. So is it possible to configure a switch for arm and disarm instead of the left stick? I mean,
Sure.
I think it supposed about to provide arm and disarm on the switch. Yeah.
Yeah, I can show you how to do that. There is a way. You can let me open the Zoom. Wait. Well, it's not going to connect. I need to connect it with a wire. So let me connect it with a wire and I will show you how to do that. So it's called ARM switch. You can set it in the same menu where you edit your other flight modes. I think I will restart the ground. The newer version of ground control for me is less stable as the previous one, but I will try to connect to that and show you. Not connecting. Well, try it again. Yeah, now it's ready. And here in flight modes, there is arm switch setting. For example, if I have a channel 7, it's not assigned to anything here. I can choose it here, and now it's the arm switch. So I armed the drone, but it's not. But the battery is not connected, so it's arming. Yes, this is how it's done. And what else about flight modes? I couldn't tell you more about other modes. So acro mode is for acrobatic flight. Then off-board mode is setting automatically when the drone is controlled by Raspberry Pi. And stabilized mode, you already know that it is maintaining horizontal flight and using accelerometer and gyroscope. The latitude mode, I don't know exactly what it does. Then takeoff mode is used when the drone is automatically taking off, and the land mode is used when the drone is landing. Follow me, well, it's probably following you. I haven't used that, so I don't know how it's working. Okay, other questions?
I was asking to show the PDB.
Oh yeah, sure. Yeah, let me show this now. Пока все в порядке. Okay, this is. Let me turn on my camera. This is the PDB, and this is the connector that you connect with the flight controller. This one. And those are the 5-volt outputs that are used for LED strip and the Raspberry Pi. So
yeah, that was I wanted. Okay.
Yes.
Okay, thank you.
Yeah, no problem. Okay, Svetlana, is there anything else?
I didn't see new questions. I think many questions will happen, then all guys will be repeat all steps which you demonstrate today.
Oh yeah.
Okay, so now I think we can finish our webinar, but before we finish, I would like to provide a summing up of our big webinar. And first of all, I would like to say thank you you guys for your efforts during this webinar, because it's a really big tutorial of the first autonomous flight. Thank you. Many thanks to Timofey. Describe and explain all details of the first autonomous flight. It was really good. And thank you, Oksana and her team, for providing this workshop and help us to organize this webinar. So, and finally, I would like to show you some important resources which you can use during your teaching operations and teaching activities, educational activities for your students, or if you're a student, you can get new knowledge using our resources. So, and the main library of our knowledge, it's of course, it's a Git book. The Git book Timofey has demonstrated today many times. But also we have many other things that you can use in your during your activity. So for it, you should to visit our website. So in our website, you can see many news about our and materials about our activities. So when we have a webinar, we announce it on our website. So you can apply on it using our website. So yeah, and here you can read the information about our products, of course. Finally, you can subscribe on our social networks and get all information using Facebook, for example. And also we have a digest of our activities. So you can check on this page, or you can click on the full calendar and be supervisor on our events. So we describe our calendar events starting from this year, and now it's more easy than before. So the next webinar will be planned on 21st April. It will be gazebo simulation first steps. And maybe before we will add some new information about webinars, and of course we announce all news in our Telegram groups or here. And one more interesting thing that will helpful for you, it's of course our education page. So this page collects all information about educational materials. So this is your this page will help you to build the educational trajectory with your students. So starting from hardware and software manuals, then participate in our competitions, and finally to create open source project and apply on Copter Hack in this summer. So, and also you can watch all materials when we have, it includes curriculums, textbook, manuals, some video materials such as webinars, video tutorials for assembling and setup. And you can know more about Clover platform. Our developers was speakers at the PX4 Dev Summit in the previous year, and in 2019 it was really interesting to listen it. And also you can watch the videos about our educational camps, and of course get more presentation about our events which was passed in this year and previous year. So you can use Russian or English for it. And this we collect very useful materials from our camps, webinars, and competitions. So it's open source and you can use it, of course.
Hello.
Yeah.
Is there any competition in future?
Yes.
In world skills competition? In
yes.
physical mode, I'm saying.
So about the more, thank you for your question. So in the summer, in July, we planned to organize World Skills competition according to World Skills Asia community. So this competition will be held in July or August. and it's open for registering, but all information will be announced some later, but you can prepare it for it. This competition will be in online mode, but now we develop two types of participating. So it can be only online, or it can be include your flight zone and performing one task on your side and demonstrate your result via online tools from your side too.
No offline competition ahead.
Sorry?
No offline competition. I'm saying.
Yeah. Unfortunately, now we don't have offline competition right now, but maybe in autumn it will be possible. So, and
Okay.
finally, yeah, thank you. So, and finally, I would like to remind you about the feedback forum. Just a moment. Yeah. So please fill this feedback form. It takes not much time, but it will really help for us to increase and to improve our events. The Google Form links was be published in the Zoom chat previously, and also we will be await the feedback from you. And finally, I would like to say many thanks to each of you, and this is our big common photo. Thank you guys for this event, and we are open for your suggestions, and of course we are ready to answer for your questions. Thank you. Okay, yeah, many thanks for your questions for today and your feedback in the Zoom chat. It's really a pleasure for us, for me, for Timofey, for all our team. And of course, today's webinar will be really great, and we have got many feedbacks and questions from you. It was really good. Thank you. Okay, guys, so I have sent the link for feedback. Please save it and leave your feedback with us. And now you can turn on your cameras, and we finalize our webinar. And we will say goodbye together in this webinar. Yeah, the recording of this video was placed on our YouTube channel. You can use this link for it. Yeah. So today we have provided the big work. So today, Timofey, today we told about competition, about educational trajectory, about how to upgrade Clover from manual flights to autonomous flights, and how to calibrate flight controller, how install Raspberry Pi, how set up the Clover Image, and how and what we should to do in the emergence cases. I think it's really important, and it was a really great event. Thank you all. Maybe if you have questions, you have a time to answer, to ask us about it.
Could you share the link of your website?
Yes, sure. The website link, just a moment. So and also I hope you joined to our community group in Telegram. If you didn't join, please join us right now, because in this group we provide all announcement of our future events and other useful information too. Okay, so guys, I see many of you turn on the cameras. It's really glad to see you. Hi, Jakumar. Hi, Ashutosh again.
Hi, nice to see you.
Yeah, great. Nice to see you guys. So now I think it's time. Maybe Timofey, maybe you would like to add something.
Yes, we actually planned to make it a little bit shorter. We didn't know it will take more than 3 hours, I guess, or how many? Yeah.
Yeah.
But this is everything we showed you today is very important and very necessary. So there's nothing that's not important. And if you want to keep your hardware safe, keep yourself safe, you need to know that. And I think we've done a great job. Thank you for your questions and for your participation and for your interest in Clover platform and our community. We hope to see your projects and your educational, your own students working with drones, and it's very interesting for us to see new faces every time. So thank you.
Okay, so now I think we can say goodbye to you all. So you can unmute your microphones and say bye-bye together.
Bye-bye.
Bye.
3, 2, 1, bye-bye. Bye-bye. See you in the next event.
Пока.
Пока-пока.